conference, or this topic is going to be covering multi-occupant vehicle energy metering and scrutineering primarily. So if that's what you're here for, you're in the right session. My name is Evan Stumpges. I'm going to be one of the MOV inspectors, along with, I think, some help with Dale Reed. I was a former Iowa State University member of Team Prism from 2008 to 2012. Now work at Caterpillar, and I've been involved on staff since basically graduating 2013 and beyond. And Dale, want to make a quick intro?
Yeah, sure. Thanks, Evan. Yeah, I was part of the University of Kentucky team. Actually an original team member, started back in 2003. So I've been helping participate in event activities since about 2012, 2013, somewhere around there. And I used to work at Lexmark. Now I work at Valvoline doing EV related work. So helping Evan here with the MOV activity.
Excellent. So these are a quick overview of the topics we're going to run through today. Touch briefly on kind of the scoring, where that landed for this 2021 event, energy metering, impound, the plans for scrutineering. I've got some draft scrutineering sheets that we can look through, and then we'll do kind of a question and answer session. Feel free to stop me at any time if anyone has questions on what we're talking about. Dale, I don't know, could you monitor the chat for me and see if anything comes through on the chat, and we can discuss that? Okay. With no further ado, let's jump right into it. So quick disclaimer, this is basically meant as a supplement to the regulations, so nothing in here will supersede what's in the regulations. If you have any questions or want further clarification on this presentation, you can send an email to ascregs@americansolarchallenge.org or contact myself or Dale, and we can help clarify as well. So let's get into MOV scoring. This is section 13 in the regulations. Overall, the goal here is to transport people efficiently along a predefined route with considerations for practicality, while driving at or above the target speed that we set for the event. This is kind of the overall scoring formula for the MOV class. It provides an S value for each team. Whether you're looking for the highest score is going to be your best score. The formula here is D divided by E times C times T times P, where D is your total person mile distance, and you're looking for higher values will be better there. External energy usage is your E value, and in that case, you're looking for lower values are going to be better. The C is your completion factor. Again, you're looking for high values. And T is a target speed D rate, where higher values are better there. And finally, P is your practicality score. You're looking for higher values there. So everything except energy, external energy usage, you're looking to maximize, and you want to minimize your external energy usage to get the best S score that you can. You might have noticed it's a lot of variables in here. It's a fairly challenging optimization problem. So be sure you have kind of a strategy of how you're handling these different factors with both the design and your operations strategy. And as always in solar car racing, vehicle reliability is important, but I would say it's especially crucial in the MOV class to have a reliable vehicle that's just able to drive the full event without breakdowns. And the main reason for that really is with relating to your target speed. If you fall below that target speed due to breakdowns, it can really kill your score, and don't want to do that. So a lot of testing before the event is a good idea with this class. Another note here, multi-occupant vehicles shall remain in the same scrutineered configuration throughout the duration of the event. All your practicality features included. So any special cool things you're doing to get a good practicality score, you can't just take them out when it comes time to do the tour. Diving a little deeper here into the different factors. So there's person mile distance. In ASC, this is going to be based on segments, which are kind of between your checkpoints and stage stops, in addition to loops. Each segment will yield a person mile distance, which is calculated as your tour distance driven in miles, multiplied by the minimum number of occupied solar car seats over that segment. And then similar to the SOV class, you are able to drive loops to increase your distance traveled. In FSGP, it's similar, but instead of segments, we're looking at laps. So every valid completed lap, you'll get a person mile distance, and that's going to be calculated as the lap distance driven in miles multiplied by the minimum occupied solar car seats over that lap.
Hey,
and
Evan,
in both, yeah,
real quick, did you push record on this?
I did. Are you not seeing something?
Somebody just asked. I thought I'd make sure before you went on. Thanks. Go ahead.
Okay. The summation of the segment lap and person or segment and lap person mile distances will yield a total person mile distance for the team, which is that final D value. Moving into external energy usage, this is the E factor. It's calculated as quantity N plus 1 multiplied by Q plus capital M. N is going to be the number of times the battery is charged from an unmetered external energy source. Q is the energy capacity of your battery pack in kilowatt hours as calculated by Steve McMullen in electrical scrutineering. And M is your total metered external energy in kilowatt hours used to charge the battery. So let's talk a little bit about metered versus unmetered energy, as both of them can be part of this total external energy usage. Basically, energy metering is going to enable you flexibility to partially charge your battery to optimize race strategy. It will also incentivize MOV teams to perform morning and evening solar charging. Metered energy or metered charging will be impacted by the conversion efficiency of your onboard vehicle charger. So for all teams who are planning to use this energy metering solution, an efficient charging system is going to help your score. So don't want to have something that's highly inefficient there. Unmetered charging is still going to be available to teams who are unable to implement J1772 or onboard charging. So if you're not able to get all this scrutineering and equipment ready to go in order to utilize meter charging and be certified for that, you will still be able to do unmetered charging. It's just anytime you plug in, you're going to be assessed the entire energy of your battery pack. So it doesn't really, it's not optimal for partial charging. And then if for any reason an external charge isn't properly metered and recorded, it's going to count as unmetered, kind of as a fallback backup. Completion factor is the next factor here in your score. It's calculated by your driving distance minus your penalties divided by the highest driving distance of any MOV team. So what that means effectively is your score is going to be impacted by the performance of the furthest driving MOV team. The next factor is target speed D rate. So we set a target average speed for our events for the MOV class. In ASC, that target speed is 35 miles an hour. And in FSGP, it's 30 miles an hour. But we do reserve the right to change this based on the track selection. Some tracks, for example, Circuit of the Americas has a giant hill, which takes a lot of energy to get up. So a hillier track, we might choose to reduce the speed for some reason. Just kind of depends on where we're at for each event. So there's a VA, that's going to be your overall average speed for your team. This is calculated in ASC.
Evan,
based it.
the,
Is there a
the
question?
slides, yeah, the slides aren't changing. I don't know if you're trying to change it, but
What slide are you seeing, I guess?
the external energy usage one.
It's the one
Is
with the
anything-
equations. It's the one with the equation still on it. The n+1 times q plus n. I think you're further than that.
Yeah, I'm sorry. I don't know what's going on. So nothing's changing now still?
Doesn't
Right.
appear to be.
Let me, did anything change now?
No.
Well, let me try stop sharing and start sharing again. Is anyone seeing my screen?
Not the slides. It's,
Neither.
Not the slides. Well, crap.
I do whatever he did a while ago.
Yeah, all right. I'm gonna drop off of the Zoom call real quick. I'll be back in just a minute and hopefully that'll get things rolling again. Okay, I am back. Let me see if I can try this again.
Yep.
Seeing my screen now?
Yeah.
Okay. So we talked about distance, talked about energy usage, completion factor. Here we are, target speed D rate. Okay. Everyone seeing this target speed now?
Yep.
Okay, great. So for ASC, your overall average speed will be your total tour distance driven divided by the total elapsed tour time in miles an hour. For FSGP, that average speed is going to be basically an average speed for all your valid laps completed during the event in miles per hour. Now what you're looking for is your average speed to be above the target event speed, or the target average event speed. And if that's the case, then your T value is going to be the highest possible, 1. However, if your average speed driven is less than the target speed for the event, you're going to be derated for this factor. And it's actually a pretty severe derate. So there's a really high incentive for you to perform at or above the target average speed. And you can see that in the graph here effectively. As you drop down even a few miles an hour below the average event target speed, your T score is going to head quickly towards 0. So this is why reliability strategy is going to be highly important here. And you don't want to just be on the cusp of like 35 miles an hour. I would give yourself a little bit of a margin there in case you do run into some unexpected things along the event. You definitely want to have a little bit of margin not to drop below that target speed. The final factor here is our practicality score. This is only a factor in ASC events. We remove it from the score for FSGP events. Practicality scoring will be determined by a panel of judges, determined by the event organizers. And there's going to be a mixture of subjective and objective evaluations. There was a question earlier on the Discord channel about this. And basically, well, we'll keep running through here. Let's see. The teams you'll have to prepare a window sticker for the solar car, which is going to describe different attributes of the car for publication through social media on the morning of judging. We may consider turning this into some sort of like a People's Choice Award through social media. Kind of have that as a separate, smaller sub-competition that may not actually impact your practicality score, but it could be a kind of separate fun thing to do. But regardless, we'll need that to be submitted to headquarters. We'll be doing the practicality judging during the rest day. So this is the day between Formula Sun Grand Prix qualifier and the start of the American Solar Challenge Tour. So there'll be a different score from each judge will be averaged into an overall practicality score. We don't release the rubric for the judging to the teams or the judges until the morning of judging. So there's really no advance notice on what you should be trying to cram into your vehicle, etc. last minute. Prior to start of ASC, our officials will review and compile the practicality scores for all the MOV teams. And your team will be provided with your own score along with a copy of the judge's practicality evaluation of your vehicle. But we're not going to make public the scores of all teams until the award ceremony. So it's kind of keep an element of surprise throughout the tour of like, how did everyone else do on practicality? And kind of keep every team pushing to do as well as they can, because you don't necessarily know how everyone else did in practicality. The following areas are things, this is from the appendix of the regulations, kind of talking about some potential things that could be part of practicality scoring. I would not say that we're necessarily going to evaluate all of these, and there might be things that aren't on this list that are evaluated. We kind of are intending to keep it somewhat vague, the intent being for MOV teams to be innovative, creative, really come up with cool things to make their vehicles as practical and desirable to the everyday public as possible. So it's not intended to be something where like, all right, I check off all these boxes and I'm going to get 100% on practicality. So we're just asking you to really think outside the box and make something cool. And these are some things listed here that are sort of an expectation in a lot of production vehicles. So having some of these or all of these would be probably helpful to your score in practicality. Moving on to energy metering for the MOV class. So meter charging, this will be the first event where meter charging is officially an option for teams. So why do we want to do meter charging? Basically, MOVs are not regulated on battery weight.
I think your slides might have messed up again.
Frozen again, great.
Yeah.
Well, I'm going to do the exact same thing I did before. It'll take me just a minute. I'll jump back in here. Sorry, guys. Okay, back again. Let me try once more. You guys seeing the presentation now?
Yes, sir.
Yeah.
Okay, let's try again. So what we were at is basically, yeah, you're not regulated on battery weight. So this gives teams the flexibility you need to appropriately size your battery to support basically your number of occupants and various practicality features and weight that you may add to your vehicle. So in previous events where we assessed teams as though they fully charge their battery from empty to full anytime they plug in is not really accurate. So previous ASC and WSC regs had a severe penalty for teams just topping off their battery with partial charges. They also encourage teams to start the last day of competition with a full battery pack, even if that's not really needed to complete the event. So by enabling meter charging, we're really allowing teams, I think, to benefit from partial charges, gain more control over your scoring formula. Why is it taking so long to implement this? Basically, we've had a lot of discussions internally back and forth with inspectors trying to reach agreement on some of the following points. One is coming up with a solution to accurately monitor charging of all these teams at different voltage and current levels. Coming to a decision to standardize on the J1772 EV charging protocol and defining minimum safety requirements for this metering process. Determining where within the charging circuit the monitor would be placed, and coming up with basically measures to ensure that teams can't bypass the meters to charge without using the meter during the event. So what are the requirements to take advantage of meter charging in our event? You'll need a securely mounted J1772 vehicle power inlet receptacle, and your vehicle is going to need to comply with the SAE J1772 EV charging protocol. If you're working with international teams that want to use a different standard EV connector that might be common in their region, that's acceptable, as long as you have an adapter cable to go from J1772 to whatever standard EV charge port your vehicle is designed to use. That in that case, you'll have to carry that adapter in the vehicle, and the adapter can't exceed 1 meter in length. Presumably, most of the teams in this conference are planning to integrate J1772 directly, so hopefully that won't apply. Teams will be required to provide their own level 1 or level 2 J1772 electric vehicle supply equipment. This is referred to by acronym EVSE, in order to charge your vehicle from an energy source during the event. You do not need to carry the EVSE inside your solar car, so that you can carry in your chase or support crew. Event organizers are not responsible for providing external energy sources or adapters for teams to use during the events. That includes both FSGP and ASC. I will note that for FSGP 2021, we are in talks with the track. They do have 50 amp, 240 volt
I think
sources.
your slide's stuck again.
This is very frustrating.
We're just on MOV meter charging. It's got one line at the top of the screen.
Stop sharing. I'm gonna try starting again. Let's see. Do you see anything now?
No.
No. Okay, we'll quit out again and I'll be back in a moment.
Yeah, it's pretty quick. Go ahead.
Okay, we'll try again here.
Yeah.
Okay, so for the FSGP 2021 at the track, they'll have 50 amp, 240 volt electric slots. I'm working with Gail to determine if that's the NEMA 1450 connector or something different. And once we know that, we'll provide that to teams. But at least at the track, you should be pretty well covered for charging. But on ASC, for example, basically either you're going to have to find energy sources along the route. If you can find J1772 charging stations, you're welcome to use those public stations around Also, a lot of campgrounds will have electric hookups for like RVs that might be good sources to be able to charge your solar cars overnight. I would recommend carrying a variety of different adapters for your EVSE so that you can plug into basically any common 240 volt or 120 volt outlet that you find along the event. And as a last resort backup, having a solution to charge from a generator would also be a recommended. You'll also need, in order to take advantage of energy metering, a rigidly mounted onboard charger that accepts external energy from 120 to 240 volt AC power source and outputs an adjustable DC current to charge your battery. The vehicle power inlet ground must also connect to the charger's AC input ground and be tied to the charger chassis if it contains any exposed metal. And the charger's AC input and DC output must be electrically isolated from each other as well as from the vehicle chassis. Any questions so far? Okay. So this is a continuation of requirements to take advantage of metered charging. Accommodations for an onboard AC energy meter provided by the event organizers is going to be needed in your vehicles. This meter is going to connect in line between the J1772 power inlet and your onboard charger's AC input. The meter connections, as described in the regulations, are NEMA 1450. You'll need a dedicated power port and charger relay for the battery box that's utilized only for external charging. So in the past, for single occupant vehicles, you may have just had a solar array power port, a motor power port. For MOVs, you also need this charger power port, and that's going to have its own dedicated relay. Any exposed connectors or conductors on this AC DC charger power lines, so basically between the battery box port and your J1772 vehicle power inlet, that's all got to be enclosed and protected in an approved manner that can be locked and sealed by the event organizers to prevent these lines from being unplugged or tapped into to bypass the meter. So there's a couple things here, really in terms of the locking or security tags, whatever, that's going to be absolutely required on any plugs or connections between the meter and your battery box. From the meter to the J1772 power inlet, it's not necessarily going to need to be locked out with like an event seal, but we don't want any exposed connectors where you could accidentally touch, and any connections in there, we don't want them to be able to be easily or inadvertently unplugged while you're charging. So we generally want them to be enclosed and covered in a way that's going to maintain a safe environment. You'll also need to provide a way to seal your charger such that you can't gain unauthorized access to its internal components to bypass the meter. So whether that's like a separate box that goes around your charger that we can lock so you can't get into it, or some way to cover the screws or access points to be able to get into that box. We'll leave it up to you, but basically you're going to have to convince us that there's no way that you can bypass this meter and tap into any other locations during the event. In terms of safety features, any covers for AC or DC power connections need to be with a non-conductive material. You need to mark them with caution high voltage labeling, and we want them to be not removable just by like a quick or easy latch or something. It should be removable covers only with the use of like tools or something that you can't just quickly or inadvertently remove. All conductors for MOV, let's see, we got some background noise on someone here, if you could mute your mic, please. All conductors for MOV charging must be appropriately sized to carry the vehicle's maximum possible charging current. And then when you have a plug connected to the J1772, the vehicle must automatically prevent the use of your drive motors. So we don't want the vehicle driving off somehow while it's charging or plugged into a charger. When charging from an external energy source, the BPS must always be actively monitoring the battery state. And if the BPS detects a fault in your battery system, it must isolate the charging relay as well as your drive motor and solar arrays has been in the past. In terms of mounting our meter, you're not going to be able to like drill holes into our meter enclosure. We may kind of experiment with this at Scrutineering. I'm thinking something like 3M dual lock to the bottom of the enclosure to either a panel in your vehicle or something might be an option, or using straps around the enclosure to a panel. Open to other ideas that teams may come up with here, but there's no like holes or something that you're going to be able to like screw through to mount the meter into your car. The display of the meter will need to be visible to read periodically during the event after you charge. Here's some reference information about our meter. So this is again something that IEF is going to be providing to teams.
If you're frozen again.
Okay, sorry, let me get out. I'll jump back in just a second. Okay. You guys seeing my screen again?
Yeah, looks good.
Okay. Yep. So as I was saying, the meter will be provided by IEF. It'll be installed in the vehicles during scrutineering. What it is effectively an EKM omnimeter pulse meter. So you can go out and look up information about that meter online if you're interested. This provides revenue grade accuracy. It's pretty flexible in terms of the input voltages and currents it can monitor. So we're basically enabling you to charge at 240 volts up to 40 amps, which should be a pretty fast charge for MOVs, we think. It's a watertight enclosure with sealed cable glands. So it's a pretty robust little box. The estimated cost of each of these is about $500. We've got a bill of materials here of the major components listed. Off to the right, kind of show the wiring of how teams will wire the J1772 vehicle power inlet to the NEMA 1450. So if you'll notice, the J1772 basically has 3 high voltage conductors. There's 2 power pins and 1 ground. The NEMA 1450 actually has 4 high voltage power conductors. There's 1 ground, 2 lines, and a neutral. On the NEMA 1450 connections, we're actually not utilizing the neutral. So it's going to be a no connect. We're taking the line 1, routing to line 1, and then we're going to take your line 2 from the J1772, and that will route to the line 2 connection on the NEMA 1450 as shown here. And that's basically what Tesla and other EV manufacturers have chosen to do. So I'm kind of matching that of not using the neutral connection on the 1450 plug. The control pilot and proximity detection are basically communication wires on the J1772. That has nothing to do with the energy metering. You'll route those straight to your presumably like a charger interface board. to be able to communicate and do the handshake and set your current limits, etc. The schematic in the bottom right of the screen here just kind of shows the sensors that we have inside the IEF meter box. So we're monitoring currents on both of the incoming lines, and then we've got voltage sensors on those as well. So really, regardless of how the power comes into the box, it's going to be able to monitor the total kilowatt hours running through it. That's pretty flexible and convenient in that regard. Here's some more pictures of the metering box. So it's basically, it's this enclosure. It'll be sealed and locked such that teams can't access it without us knowing. And on the inlet side, we've got a female connection, NEMA 1450. On the output side, we have a male plug, NEMA 1450. And on the internal power connections, you can see the little terminal block there. We've got our line 1, neutral, ground, and line 2, current transducers, voltage sensing, etc., all in there. When you're not at the event, basically you can connect your NEMA 1450 connections directly together. When you come to the event, you'll plug them in. Basically, our meter will be plugged in line. I've included some dimensions there. This is all available in the regulations for reference if you need. Oh, sorry, I'm going to go back. The meter will cycle through a display during the event. It's about 2 seconds per cycle. The first reading is the total kilowatt energy. This is a non-resettable value. So basically we'll take the value at the start of the event to the value at the end of the event. That's going to be the total energy you charged into your vehicle through the meter. And you can periodically take measurements over time and see like how much did I charge over last night or over this stage, etc. The next cycle, it cycles through the voltage on line 1 and line 2, and then the amperage on line 1 and line 2. So you can see that in real time as you're charging, or if you're troubleshooting something going on with your charging or incoming power connection, you can see that. Next, we're going to talk about MOV impound and what we're requiring there. So multi-occupant vehicles are exempt from the requirement to remove the battery pack from their vehicle for impound purposes. These batteries are just too big and heavy and bulky in many cases to practically remove from your vehicle. Instead, we're requiring an alternative, reliable means to secure the batteries, protect from any unmetered charging during impound hours. So what does that mean? Basically, you're going to need to be able to lock out any access to your battery box lid and any power connectors to the motor, solar array, etc. In this impound state, the only power coming in and out of your battery box is going to be able to be through your J1772 metered power. So we don't allow any like externally accessible hardware on, say, like hinges to your battery box lid. If you got screws and stuff that you could take apart, put those on the inside. Make sure there's no way once we put our little seal or lock through the battery box lid overnight for this impound solution, you can't get in there. There's no options. That's what you're going to have to prove to us. And likewise on the power ports, most likely the easiest thing for you guys to do will be to unplug your motor and solar array connections at the back or wherever they enter your battery box, and come up with some sort of cover panel that can be locked and covered over those connections so that you can't plug in any other devices to charge your battery box and bypass the meter. Any questions on this? Basically, it's going to be up to you to prove to us in this impound state, and ideally minimize the number of places we have to put locks or security tags to do this. But the only power access to the battery pack in this state can be through that J1772 power inlet.
Yeah, I have a question.
Sure, go ahead.
So for that locking, or essentially to secure it, the way that we did it in, I think the 2019 one was just zip ties, if I remember right.
Yeah,
that you guys
basically
provided?
we have like it's almost like a zip tie. It's a little security tag. It's got a number on it. We checked that the same number's on there in the morning, and you haven't cut it or tampered with it in any way. That's the most likely easiest way to do things. So if you have a little hole slots that a little zip tie like thing can go through and lock out, that's very convenient. We're open to other ideas you guys may have, but if you're proposing something radically different than that, it might be good to contact us before the event and get authorization.
Okay. Yeah, I just wanted to check if that was still going to be a thing.
Yep, that's going to be my preferred method, is the little like zip tie security tags.
Yeah, makes sense. That worked for us before, so.
Great. So failure to properly impound during the designated hours of the event will result in basically a full unmetered external energy charge being added to your score. So let's talk about when it's okay for an MOV team not to impound. As mentioned in the last slide, anytime you fail to properly impound during designated hours, you're going to get charged as though you charge from external energy, which is basically the entire energy of your battery pack being added to your energy score. If you elect to charge from an unmetered energy source, you need to first give official notice of your intention to do so. So that would be either to an event organizer or your observer during the tour portion of the event. And if you are going to be charging from an unmetered external energy source overnight, you do not have to impound that night. So why might you choose not to do metered charging? Basically, there's a couple options or a couple reasons why you might not want to do meter charging. One would be if you aren't given certification for meter charging during scrutineering, you fail to pass the MOV energy metering scrutineering portion. You can still basically operate as you would have in previous MOV competitions in ASC. So anytime you plug in and charge, basically we're assessing the entire energy as though you've fully charged your battery pack. Why might you fail scrutineering? So if you don't have a onboard charger, a functional onboard charger, or J1772 receptacle, or you don't have the right EVSE equipment, you're not going to pass scrutineering for MOV. That would be one reason. If your vehicle, for whatever reason, can't accommodate the onboard IEF energy meter, that would be another reason. Or if you don't satisfy our requirements for impound, safety / lockout requirements, are all different reasons that you might not get certified to be able to use metered charging during the event. In all those cases, you're perfectly welcome to charge via unmetered as a fallback option. One other interesting possibility why you might not want to use metered charging is if say you're at the end of the day and you've drained your battery pack 100%, you think it's dead completely. If you do an unmetered charge, you basically get to bypass your charger. So your charging efficiency, say your charger is 90% efficient or something, you could bypass that charger inefficiency by doing an unmetered charge if you think your pack's completely dead. If you're thinking about potentially using that, I would maybe do some testing in advance to see if you'd really get a benefit or not from doing that. Because a lot of times your battery pack with your BPS limits are not really going to enable you to use the full 100% of your energy capacity in the battery. So you might or might not get a real benefit there. But if your charger is not very efficient, there might be a real possibility that would be something worth considering. Any questions on that or anything related to impound so far? Okay, we'll move on. Let's talk about MOV scrutineering. I'm going to stop the presentation real quick and hopefully this will work for everyone. What I've got, let me see if you're seeing this. This is our draft scrutineering sheets for MOV station.
Yeah, it's there.
Okay, excellent. So this is kind of an overview of what Dale and I will be kind of checking through on your vehicles as you come through our station. So anywhere you see pass-fail criteria, that's kind of going to be like whether or not you can successfully certify for meter to energy. If there's yes or no boxes, this is more just kind of like an informational and understanding your system, but doesn't necessarily indicate whether or not you'll be able to utilize or be certified. So first check here, is your vehicle charger rigidly secured in the vehicle? Pretty easy, yes, no. Is your charger protected from water ingress? Yes, no. We don't want your charger, say right below a seam in your canopy where you're gonna get rain coming in on it if it starts raining. Is your charger able to accept input voltages from 120 to 240 volts AC? Yes, no. We'll record your charger power rating. This is something I'm kind of interested in, if any teams have really worked through this so far, as to how your DC current request is being developed. I guess DC and AC, because the J1772 sets basically a current limit of how much energy your vehicle is able to pull or wants to pull from the wall. And then the EVSE also has its own limit, like you can change limits within there. So basically different things you may need to be considering in this is like how much does your battery management system say your battery can take? So if you're getting towards the top of your battery pack and it's almost fully charged, your BPS is going to start dropping that current limit and you're going to need to request less current from the J1772 protocol. It's also possible you might want to be able to set a user settable AC or DC charge current limit. Like say you're on a circuit that you know has a certain fuse in it or a certain breaker in it and you don't want to exceed that. You could just manually possibly enter some current limit as a user of the vehicle. Then there's also the pilot control max AC current limit from the EVSE. And then also thinking about how you're converting your max AC current limit to the DC charge current limit. So like your battery is going to be charging at a certain voltage and current, you've got a charger efficiency. So just making sure you're converting correctly between those so that you can request the right amount of AC current limit. Honestly, I have not implemented J1772. So for teams who have and have input on these topics, I'd be definitely interested in discussing further offline on this section in particular. Okay, moving on. Do you have a standard EV power inlet receptacle present? Yes or no? Is your vehicle power inlet securely mounted to the vehicle? Do you require an adapter or for J1772 to plug into a different power inlet? So if you're coming international team, have a different standard EV adapter besides J1772. You'll need this adapter, can't be more than 1 meter in length, and it'll be carried in the vehicle when not in use. We'll assign you an IEF meter. We'll give you we'll record the number of the meter here, and we'll expect that meter number back at the end of the event. Here's the requirements for the NEMA 1450 inline connection so that we can plug the meter into your vehicle. Is the meter able to be mounted in a location that can be visibly read after charging? Is your charger sealed to prevent unauthorized internal access? Is your battery box, or does your battery box feature a dedicated charging power port and relay? Some of this stuff will be looked at probably in the electrical station, and this is more just of a quick verification and check. We may ask to look at your high voltage onboard electrical schematic in this station just to kind of confirm how things are getting wired up with relation to the charging circuit. In terms of charging safety, we're going to be asking for confirmation that your BPS is actively monitoring and protecting the battery during charging. When the main power switch is controlled by the BPS opens, we want to make sure that the output of your MOV charger also disconnects from the battery pack. The onboard charge current is automatically limited by the BMS as it approaches full charge to avoid BMS or BPS faults. So yeah, again, as you get close to full, that charge current is going to need to ramp down to avoid overvolting your pack. In terms of your conductor, or sorry, your connection covers, we're going to be checking that they're non-conductive, that they would be requiring use of tools to remove. So again, we don't want any like flimsy little things that you can pull off by hand easily, quickly, and inadvertently expose high voltage. So we'd like something that like bolts on, screws in, things like that. We'll be checking for your labeling, caution high voltage on all of those covers. And then we'll also be asking you for the wire gauge of your AC conductor size and your DC conductor size, the smallest within your charging system, to make sure that you're going to be appropriately rated for your charging currents. We'll ask you if you have J1772 EVSE equipment, yes or no. And then we'll check if you have the ability to plug into a standard NEMA 515 120 volt outlet. So this is kind of like the bare minimum. If you don't care about fast charging, just about everywhere is going to have this 515. This is your standard 3-prong household electrical plug. Like your vehicle should be able to, at a very minimum, plug into one of those and charge through the J1772. We'll ask if your vehicle is 120 volt AC compatible. I guess the only time maybe you wouldn't have this, I know some like European teams have 240 volts as their standard like household electrical. And so it's possible maybe some international teams wouldn't have this capability. They'd only be 240. So it's basically just checking if you can charge at 120 VAC, 240 VAC, and what's the max current in each of those conditions that you're allowing your vehicle to charge at. And then do you have a generator that can be used to charge the vehicle? This is just kind of an informational thing. In terms of impound, we'll be asking a confirmation. Basically, are you planning to impound in chassis? I'm expecting almost all of you will be. I think maybe is there a question?
No, I think it's frozen again.
Oh, frozen. Okay, sorry. I'll jump out and jump back in. Let's try again.
Yep.
Okay, we're back. We'll be asking about your impound solution and strategy. So I'm assuming almost everyone's going to be impounding in chassis. I think maybe Minnesota did external impound in the last event. Basically, if you're using energy metering, you're going to be impounding in chassis. If you're not, then maybe some teams will still do external impound box, but we'll see when it comes time for the event. But basically, we're going to be checking for the ability to lock and seal all these different areas that would give you access to high voltage. So your battery box lid overnight, we need to be able to seal that. Yes, no. Power ports to the motor, power ports to the solar array also need to be locked. And then any other connectors or conductors. So who knows what else you might be powering out of your battery box with high voltage besides motor and solar array. Those are the most common ones. But if there's anything else, we'll check for it and we'll make sure you can lock it out. Then in terms of certifying you for the MOV charging and testing, basically we'll plug in the IEF onboard energy meter in your vehicle in line, make sure that we're able to do that. And then we'll be doing some, before we run any power through anything, we'll be doing some basic safety checks on the system. So we're going to verify that the neutral on the NEMA 1450 has no continuity with other terminals. We're going to check that the ground has continuity with the vehicle power inlet on your G1772 and any exposed charger chassis metal, but not to any of the other terminals. We'll check that the line 1 and line 2 have continuity with the correct vehicle inlet power port, but no other terminals. And then we'll be looking at isolation of power conductors. So we'll verify that your AC side power to DC output on the charger don't have any continuity there. We'll be verifying that your AC input conductors are isolated from your vehicle chassis. The DC power conductors are also isolated to vehicle chassis. To do this, I've got a mega meter that can apply voltages up to, could go up to 1,000 volts. For this, we probably would do like 250 or 500 volts. Maybe I'll talk more with Dale about what he would recommend there, but we'll be checking basically isolation on all these different areas that we expect isolation. And if you have any issues there, you'll have to fix that. Once we verify that isolation and connections are basically correct within the vehicle, we're going to have you demonstrate charging with your own EVSE equipment and show us that you're able to charge. Then we'll also,
Evan, we'll probably do that with ours too, maybe, right?
Yeah. Yep. So first I'm going to have them do theirs in case something blows up. They'll damage their equipment, not ours. And then we have our own EVSE equipment, which we know is certified and complies with the standards. So we'll also have you check with our equipment. And basically what we're looking for there is that your vehicle is able to perform the correct handshakes to initiate the charging, and that you're able to respond to current limits from the EVSE. So basically, and we'll also check the proximity pilot verification. So if we remove the proximity detection signal, like get it ready to unplug the connector, for example, from your vehicle, that should safely shut down the charging. So we'll basically do some pretty basic functionality checks to make sure that you're able to successfully charge your vehicle with standard J1772 EVSE. We'll also check that the onboard energy meter is reading correctly based on the little bit of charging that we'll be doing. We'll also verify that your drive motor is not able to run while the J1772 plug is connected. And then we'll be looking at some things. So I have some test plugs that kind of can simulate either a broken ground where the ground is not present, and also a ground fault scenario. And we're going to see if your vehicle is able to detect and prevent charging in those scenarios or not. Then we'll finally be checking that all exposed conductors on the AC and DC charging power lines are physically, let's see, what am I saying here? That we have an ability to lock or seal all conductors or connections on the AC and DC charging lines between the battery port and the power inlet. So we're trying to prevent you from being able to disconnect any of these or tap into any of these, bypass the meter. Based on the scrutineering, you're either going to be certified or not certified for metered energy charging in the event. If you fail this station, you can still participate in the event, assuming you meet the safety requirements of the scrutineering. If it's just a matter of not having all the right equipment or being able to demonstrate J1772 charging and stuff, that won't eliminate you from participating in the event. It just means you're going to have to do unmetered charging, and every time you charge, you'll be assessed the full energy of your battery pack. What we need to enter this station is a fully assembled solar car. You'll need to be at least yellow in battery and BPS, and you'll need to bring your vehicle electrics or vehicle supply equipment for charging. Any questions on the proposed scrutineering process for MOV? In that case, I'll jump back. Are you guys still
Hang on, maybe stay right there a second.
on the scrutineering?
Yeah, just right where you are.
Yep.
We were talking the other day, and I think that we concluded that, like, I think this second to the last, well, I guess it is the last pass-fail box.
Yeah.
Right? This is lock, / seal, all exposed connectors on the AC DC charging power lines between the battery box and the vehicle power inlet.
Yeah.
So I think that what we clarified is that, let's say, like, from the inlet to the meter box, because it's before the meter box, like that is not a section of the cable that'll have to be locked. It's like
right, yeah,
after the meter box, right? So this may be a little bit more encompassing than our intent. So if I read it correctly, but
so this is how the regs were written to date, but after discussing yesterday, I think I'll allow some leniency, and we may even put an update into the regs wording in this box wording. The places that we really need a lock are from the meter to your battery box. So the meter to the charger to the battery box. The connections between the meter and the J1772 inlet aren't necessarily going to need an IEF seal, but we still do need those to be, I don't want you to be able to like have someone come up and inadvertently unplug something while you're in the middle of a charge. That would be a safety hazard. So it needs to be something that's like strapped or secured or enclosed, covered, such that you can't just have one person easily come up and disconnect it while you're charging. But yeah, it's true. We won't necessarily require an IEF seal on connections between the J1772 inlet and the energy meter itself.
yeah, so I think we maybe covered that.
Okay, yeah, hopefully that clarifies.
Yeah, and so just from my point of view, like I get really picky when it comes to like exposed primary power connectors. Like
Yep.
we're going to make sure nobody can access that, right? I think the regs even stipulate, like if
Yeah.
primary power connectors have a cover, the cover, it can't just be like snap away or whatever, like Evan said. I mean, it's, like
Something you got to get out tools and
yeah, like you have to
loosen
get
4 bolts or something. Yeah,
right,
it's got to
like
be
socket
substantial.
wrench, like you can't, as in you can't do it with your hands, right? Like like tools are required, so AC conductors, AC, like the terminals to the pins, whatever, right? It's just inaccessible by human, covered with covers that require tools, and again, like clear plastic covers are good. This is all from the regs, right? Just so you can see what's going on inside there. It's for your own benefit. So.
Yep, very good point. Okay, let me jump back here real quick. Are you guys still seeing my screen?
I'm still on yeah, there you go.
Okay.
So, question, Evan.
Yes.
I'm not sure. I don't think I understand that correctly. So what you just said was that the connection between the meter and the J17 at the car, that connection does not have to be have tabs to where it can be zip tied or proof lock.
Well, I'm going to get more to that in this slide. So if you wait just a second, we'll kind of show the different places and the different levels of security that are required. So
Okay.
this, if you're seeing my slide here, this should be kind of an overview of the major components of your charging system and vehicles. So we start J1772 inlet, then we're gonna come to our NEMA 1450 connector. It's gonna run through our IEF meter to another 1450 connector to your
Oh.
onboard battery charger.
Are your boxes started to show up yet?
No, they'll come in just a minute, but
Okay.
I'm just explaining the layout so far.
Oh, because yeah,
Uh,
just making sure
yeah.
it wasn't frozen. Go ahead.
No, it's not frozen, or not yet. I'll let you know when I start flipping through those. Then we've got the main vehicle battery, and then you've got your motor controller and solar array and PPT connections. So in terms of what we're going to require in order to be certified for energy metering, these locations in red, your battery box and onboard charger, we are going to need the ability to have an IEF lock, or some proof that your team is not able to access these components without our knowledge to bypass the energy metering. So what does this mean for you? Like if you need a service, your onboard charger, you have a failure in there or something, you're going to need to come to your observer or an official and get access to remove the lock temporarily, do your service, and then we'll reapply the lock. Same with your main vehicle battery box. The connections shown here in yellow are going to be required to be locked out with an IEF type seal tag that you can't plug and unplug a connector or bypass any of these locations. During impound, you'll need a method to isolate and lock out the connections to your motor controller, solar array, any other high voltage power ports to your battery box. So other than the charging line, if that makes sense. The IEF energy meter is going to be provided sealed. So it's got a little hole through the lid, and we've got seals that will go in there. There should be no reason that you get into our IEF meter for any reason during the event, and we will know if you do. Finally, these two connections are the ones we were just talking about before. They don't necessarily need this IEF seal or tag, but we do need them to be protected from inadvertent disconnection during charging. Like if you're charging at 240 volts and 40 amps or something, and you disconnect this connector, like this NEMA 1450 or something, while you're charging, there's a big safety risk there. You could have arcing, and we definitely don't want that. So we need like straps or some way to securely hold these connections together, and we can talk through that at scrutineering. This is kind of both IEF and you working through a way to secure that NEMA 1450. And then on your J1772 power inlet, the wiring connections into that, if you could have some sort of a enclosure over there that screws on and stuff that you can't touch or access any of those wires or connections, that's what we're looking for there. And finally, the inlet port of that J1772, this is wide open. It's the Wild West there. You guys can charge anytime you want during the event, during racing hours, during the evening, during solar charge. This is open. Obviously, it's not in your best interest to be charging during the racing hours when you should be driving. It's going to hurt your distance score. But if you run out of charge on the road or something crazy happens, there's nothing preventing you from charging at any time through this inlet, and all of that energy will be metered. So that kind of makes sense here with what places we're worried about having locked out with IEF tags. Okay. We're gonna go to questions and answers session here, and I'm gonna start with a couple questions for teams, I guess, and then we'll kind of open it up to a general forum. I guess of all the teams here present, are any of you not planning on using metered charging? I'm assuming most of you are probably trying to work towards meter charging. So for those of you who are planning to use meter charging, do you guys already have EVSE charging equipment that you've procured and are working to test and validate with your vehicles? Does anyone have experience with this so far?
We don't have experience with it yet, but I know that we have the hardware and we're working to test it soon.
What team is this?
Oh, sorry, NC State Solar Car Team.
NC State, okay. Anyone else have any experience or equipment that they've been working with there?
It's not my area of specialty, but our team, I think you guys provided us with one of those what
Is this Calgary?
Yes, Calgary.
Yep, okay. I have the most confidence in your team's ability to do meter charging since you basically had the entire setup last year. That was
Yeah.
awesome.
Yeah, we actually just lost all of our data for the metering though.
Oh yeah.
Yeah. One of my members did want to talk to you about like they wanted to discuss with that metering and the
Okay.
J1772 integration stuff.
Would be very happy to discuss that further. Yep. Any other teams have you EVSE equipment yet?
Yeah, we have our EVSE equipment.
Have you got to implement it at all or test it or not yet?
Yeah, it's been implemented, but it hasn't been tested yet. This is a University of Waterloo, by the way.
Okay, excellent. That was my next question, is how many teams have implemented and tested. So I know Calgary has, because they ran with it last year. I was very pleased to see that. So if anyone's having trouble with it, I think Calgary might be a team to contact and potentially ask questions to. Here's a question. Have any teams, and I guess if Calgary's maybe the only one who's done this before, but have any teams tested charging J1772 from your portable power generator?
I don't think we have.
Okay, I would be very interested to see if and how well that works for you. I know some generators do different things with like earth grounding, and J1772 may have certain requirements for being used with a generator. So I don't know if it'd be universally compatible with all generators or if you need kind of special generator equipment, but I would be interested to hear any experiences from that.
Yeah,
if you guys get a chance to try it.
Yeah, for sure, something that we'll be testing in the future.
Okay.
And we will let you know what we see or what we find.
Here's another question. This hasn't been officially agreed upon or formalized yet within our internal staff, but I'm kind of curious if any teams would be interested in gaining advanced access to one of our IEF energy meters to integrate and test in their vehicle. We'd basically probably be looking at a $500 deposit to do this. It would be refundable when you return the meter to us after the event. But this would give us some advanced experience or indication if there's any challenges or issues with integrating this into your vehicles, and also save us the effort of transporting some of these to the event. So you don't have to necessarily answer today, but if there would be interest, maybe think about it in your team, and we'll probably be putting out a request at some point in the future to determine if there is an interest here.
I can already say that Prism would be interested.
Okay.
I'm pretty sure NC State Solar Car Team would also be interested.
I think App State would be interested too.
I'm guessing they all will, yeah.
Yeah, it seems like a pretty good idea. Obviously, this is the first time we're going with this onboard energy meter. So if we run into issues the first time during scrutineering, we're not going to have a lot of time to react to that. I've done quite a bit of testing myself personally with the meters in different scenarios. I have a Tesla Model 3 that I've run through it, charged multiple times, and I've charged various different things through the meter to kind of validate different scenarios. So I have pretty high confidence in it, but again, just interested in getting it out into vehicles sooner to see how you guys do with implementing it in your vehicles. I guess with that, that's all the information that I had prepared. If there's any questions, concerns, I'm certainly happy to stick around. I've got about another 15 minutes here before the next sessions. But I thank all of you for your interest in the MOV class, and I think it's exciting that we're at this stage now.
I've got a question about what counts to tour time during ASC.
Okay.
So basically, I guess some of us were wondering, this is Waterloo, by the way, does stopping on the side of the road count towards tour time? And then that means our average speed would go and decrease as well.
Yes, that's why you need a reliable vehicle.
Right. Yeah. Okay. Just making sure.
Same thing with, like, if you stop to charge on the side of the road or whatever, or at the charging station along the event, that will be counting towards your tour time if it's during racing hours. Obviously, if it's during evening hours after racing hours, you're free to go charge wherever you want, and that won't impact your time. But yeah, anything during the day, racing hours, you're on the clock, so you should be driving if at all possible.
Yeah, that makes sense. Thanks.
Yeah, I have a question. So my team's always done single occupant vehicles before.
Okay.
Would you, or I guess anyone else, have any advice for, well, right now we're just toying with the idea of an MOV in the future. Advice for transitioning from the single to multiple?
Add more seats.
It's I would say it seems like a bigger undertaking and endeavor. So in terms of like team member resources, if you're a smaller team, I think maybe an MOV would be more difficult to pull off. Also, obviously with this J1772 implementation and charger, onboard charging implementation, it's going to require some like power electronics experience and integration, which might be different than you would need necessarily, or you probably wouldn't need quite as much of that on an SOV class. There's also a lot more consideration into like aesthetics and industrial design to try and have a more practical or more normal looking vehicle. A few things that come to mind. Bigger battery pack, maybe a more expensive project than a single occupant.
Make sure you're at the point where you have like a very reliable stream of money, and you're not with every Challenger you build, you're not at the point where you're basically out of money, because it takes a lot more money.
Yeah, probably bigger everything, right? Bigger, maybe potentially bigger motor or multiple motors, you know, tires and golly, just everything, right? So
I think I heard from one of your members that your shop is not super huge. That's definitely a problem we run into. We just moved into a new shop, and having this massive car does not leave a lot of room to work.
I'm speaking for App State. We've done both vehicles, and one of the things I've noticed is that it's a different dynamic it's totally different when you go to a competition. Your strategies are so much are vastly different. This metering, charging, and you think of it's a different, just a mindset as a whole, and be prepared for looking at everything through a different lens when you're planning for if it's a dual motor system or a bigger motor system or just tires. Everything is just a different world, and it is a different challenge for sure. Sometimes I look back, I'm the advisor, so sometimes I look back and I wish we were back in the Challenger class. And then sometimes I think, wow, I'm really glad I'm in the MOV class. So it's just a totally different mindset, and it's a different race altogether.
Another thing with that is you want to make sure your team is like very morally strong, just because you're going to run into a lot of challenges, and you guys need to be okay with some setbacks because they'll happen.
I like the fact that Michigan's not in it, so it's kind of a wide open field.
That's the only reason I joined an MOV team.
But I agree. There's a lot of challenges and a lot of opportunities.
Yeah, that's really helpful. Like my team's kind of at from what I can tell, I think it's kind of a transitional period right now. If we wanted to make that change, now would be the time to kind of do that. So thanks for, this is helpful.
It's much more like if any of your team members are interested in working in the EV industry someday, like the MOV is kind of a very natural way to progression into that. It seems much more relevant and closely aligned to like battery electric vehicle design. You're talking more of a bigger battery system and charging implications. So a lot of good experience that your members can gain for that industry, which is definitely booming right now and probably will continue to do so for a number of years.
Yep. So we're reminded we need to wrap up pretty soon here.
Yep.
But yeah, I totally agree with that. That's what I was thinking. It kind of forces you to learn more about, even though it's not a huge step, but just because it's so voluminous to build a car, right? How much more work you got to do to throw a charger in it? But it does force you to learn the connectors and the compliance of the charging and just how the world of charging works, right? So all that's pretty cool.
Yep.
So
sorry for all the disconnection issues throughout this. Don't know what was going on there exactly.
So I think the next one starts here in a few minutes, right, Evan?
Yeah, I think if there's any other questions, there is a channel out there for MOV discussions. It's under the regulation section of the Discord. So feel free to keep this conversation going. Any questions that you have, we'll find a way to get this presentation out to teams as well as the draft scrutineering sheets. I'm always accessible via email. Feel free to reach out with any questions or challenges you guys are running into. I know I'm going to be talking with a few teams on one-on-ones here tomorrow, so looking forward to that.
If you care to, I can take questions as well. I especially get interested in like the AC side of things, just because that's like a previous area of expertise, right? So I'm pretty comfortable working there. Just ask away.
Yep. Okay. Well, thanks everyone for attending, and have fun with the rest of the conference.
Yep. Good luck with your builds.
Yep.